Hello guys, welcome to my channel. So this is part 2 for SFD and BMD. So in this video also I am going to solve 3 numericals. So let's start. So first question will be same cantilever. This is your point load, and sorry, this is your concentrated movement. Let's assume 2 Newton meter, and let's assume this point load as a 10 Newton, and this is as a 5 Newton. Okay, and let's take length as a 2 meter, and this length as a 3 meter, and this length as a 2 meter. Okay, so for this how to draw SFD and BMD. Okay, so actually it is very simple. So let's see how to draw. So this is your 0 Newton SFD. Okay, yeah. So for this how to draw SFD and BMD, see, first I will start with SMD. SFD. So like basic things, see, suppose this is your beam, and if you are applying some load. Okay, so suppose this P load, and in this beam, like this part will go down, right, and this part will go up due to like this, due to this force. Okay, so this part we are going to draw in SFD always. Okay, and in this case we have to consider as a positive, and if your load is like downward, then we have to consider negative. Okay, yeah. So, and one more thing, due to this movement, concentrated movement, in your shear force diagram there will be no effect. Okay, for this, because see, suppose this is your beam, and if you're applying some movement, so this movement can only bend your beam, right? It cannot shear. So that's why, due to concentrated movement, your shear force diagram will, like, it will not affect. Okay, yeah. So due to this 2 Newton, nothing is going to happen in your shear force diagram. So there, here up to this your 0. Okay, up to this 0 shear force, and then here this is 5 Newton, right? So this will directly your 5 Newton. See, I can write reaction. Suppose this is A, so Ra is equal to this 10 Newton, so equal to 10 plus 5. So your Ra total is equal to how much? 15 Newton. Okay, yeah. So this one here, up to this there will be no any force, so that's why up to this is constant, and this is 5 Newton. See, here directly one load is coming, point load. So because of this, sudden jump will come. Okay, sudden jump will come, and here will be 10 plus how much? 5. This is, here will be 15 Newton, and again there is no any load, so up to this will be constant. And see, up to here how much? 15 Newton, right? Up to here 15 Newton. To balance this beam will regenerate like minus 15 Newton. Okay, so that's why we are getting here 0 SFD. So this is your SFD for this diagram. Okay, yeah. For BMD, how to draw BMD? See, that also very easy. This is 0 Newton meter BMD. Okay, yeah. For BMD, let's see some basic things. Like in this case, suppose this is your beam, and this movement is like this 2 Newton. So this, for this, like if you're applying movement, concentrated movement like this, so in this case your beam will bend like this, right? Your beam will bend like this. So in this case we have to consider hogging. Okay, so in case of hogging, sign we have to assume negative. Okay, in case of hogging we have to consider sign as a negative. And same case, see, so this is same case in our case, like in question given. So in this situation we have to consider, we have to check what we have to consider negative sign. So one thing like sure, we have to draw in negative side. Okay, yeah. And one more thing, suppose this is suppose movement is nothing but force into distance, right? So at this point, see, one more thing, see, this movement 2 Newton movement is constant for whole beam. Okay, it is like here, everywhere is 2 Newton only. Okay, yeah. So this is 2 Newton will sudden jump. So this, due to this 2 Newton, see, due to this 2 Newton, this will be your 2 Newton, sudden 2 Newton will jump. So this is your 2 Newton meter. Okay, yeah. Then up to this there is no any other forces, no load, so up to this it will be constant. Okay, see, up to this it will be constant. So up to here 2 Newton meter. Okay, Next, suddenly point load is coming, right? So point load is coming. For that, let's assume up here, let's take some length like x. So for this, how to write bending moment? See, so suppose this is 2 Newton is directly, so we can write directly, and this 5, so minus, see due to this point load also, suppose this is your load and this is also feeling what, sagging only, right? This is also, sorry, hogging. So this is hogging. So in case of hogging, we have to consider negative. So this will, in this case also, we have to draw in negative direction only, right? So minus, and this 5 into x, right? See, so this will come what, in which curve this will, this is nothing but linear only. So as you are increasing your x, your movement is increasing, right? So see, so this will increase linearly up to how much, up to this, okay. See, up to this it will increase linearly. So here how much movement we are getting, here movement we are getting, see, suppose let's name it a b c, sorry, this is c and this is d, okay. At b, how much bending, how much movement is there, bending moment at b. So see, at b movement is how much. So at b movement will be, see, so this is your direct 2 Newton, which will be negative, and this is 5 minus 5 into how much distance is there, 3, right? So 3, okay, and 3, so minus 2 minus 15, so minus 17 Newton meter. So at this point, how much we are getting moment, minus 17 Newton meter, okay, minus 17 Newton meter we are getting moment. Yeah. Next, see, same for this 10 Newton also, it will come same curve, like this, linear only. So for this it will come like this, okay. For this it will come like this, and at this point, suppose we have to find moment at point A. So for this, see, to find moment, see, to find moment at A. So how to find moment at A? See, this is 2 Newton, we have to take negative, so this is minus 2, and it is directly movement, so we have to directly we have to write 2, and then this is minus, this will be your, so this is 5, so this is your 5 into this distance, how much, 3 plus 2, 5, so we have to consider this 5, okay, and minus this 10 Newton is also upward, so it will also, this, in this case also we have to consider movement as a negative, so 10 into 2, right? So this will be 10 into 2. So see, movement at A, how much, movement at A will be, this is minus 2 minus 25 minus 20, right? So this will be your how much, so this will be your 27, and this 47, right? Yeah, 47 minus 47, okay. So this is your how much, minus 47. So at this point, how much movement we are getting, here we are getting minus, here we are minus 47, okay, minus 40. To join this, this beam will create, plus 47. So that's why, like plus 47 this beam will create. So that's why at this point we are getting negative, we are getting 0 bending moment, okay. So here we are getting minus 47, okay. So this is your minus bending moment for this question, okay. Yeah, so I will take another example. So another example is, suppose this is your beam, and let's take, suppose this is your moment 2 Newton meter, and this is your moment 3 Newton meter, and suppose I will take one point load here, suppose this is your 5 Newton, and I will take one more, yeah, so this is your moment as a 5 Newton meter, okay. Yeah, so I will solve this one more question. Yeah, so for this, suppose assume length as this is 2 meter, and this length as a 2 meter. this length has a 3 meter and this length has a 2 meter. Okay, yeah. So for this how to draw SFD and BMD, actually it is very simple. So let's see. First we'll start with SFD. So this is 0 Newton SFD. Okay, yeah. So first name it. Suppose this is A, B, C, D, E. Okay, yeah. So for this how to solve? So first start with SFD. So see, SFD I will start here. In case of SFD, like see, first I have already explained you, in case of SFD there will be no effect for this concentrated movement, right? So one thing we are sure, for this 5 Newton there will be no any effect in SFD diagram. Okay, yeah, there will be no effect in SFD diagram. Okay, so one thing we are sure, here your SFD will be 0 in this region, right? So due to this 5 Newton only SFD shear force diagram will appear. Okay, due to this 5 Newton. So this, because this load is upward, this load is upward direction, right? So this load is upward. So see, suppose this is your beam and this is your load, this is 5 Newton. So this is your load, so this beam will go down and this beam will go up. So in shear force diagram only this beam we are going to draw. So this suppose this is your 5 Newton, so this is also your 5 Newton, right? Yeah, so this is your 5 Newton and up to this there is no any load, right? So this is your 5 Newton and here also no load. We are already know, like due to movement there will be no effect in CFD diagram. So up to this it is constant. Okay, and see, this is your 5 Newton. So to balance this beam will generate minus 5 Newton. Okay, so finally here we are getting 0 SFD at this point. Okay, so this is your SFD. Yeah, next, to draw BMD, see, to draw BMD, so this is line 0 Newton meter BMD. Okay, yeah. To draw BMD, see, and here reaction how much? Suppose this is RA is nothing but 5 Newton only. Okay, yeah. So see, for movement at, first we'll find movement. See, I will start from here. So movement at A. So movement at A is nothing but here directly given how much? 5 Newton. 5 Newton meter. And to check the direction, see, direction, suppose this is your beam and this is your movement, right? 5 Newton meter. So this movement will bend your beam like this, right? Like this it will bend. So this is nothing but hogging. Okay, so in case of hogging we have to consider negative sign, right? In case of hogging we have to consider negative sign. Okay, yeah. So this, due to this 5 Newton, this we have to draw negative sign. Okay, due to this hogging effect. So this will, and one more thing, this 5 Newton is constant for all beam. Okay, like here in every beam, like in every beam, like all section it is constant. Okay, so see, this is 5 Newton, so it will suddenly, this is 5 Newton. Okay, and yeah, so up to this it is constant 5 Newton up to here, and this 5 Newton is coming. So see, this is 5 Newton, right? So suppose we want to find movement at this up to here, right? So suppose assume some length are there. Suppose this is length is x. Okay, suppose this length is x. For this we want to find moment equation. Okay, so see, so moment at after D, like just after D we are finding. Okay, after D, moment at after D. Okay, so see, after D how much? So this is your 5 Newton. See, this is your 5 Newton, right? So 5 Newton is nothing but negative only. So 5 Newton acts, and it is directly movement. So I can write directly 5 Newton. Okay, next, this is your 5 Newton. So minus 5 into, and I have assumed length as a x, right? So see, so now this moment is depends upon x, right? If you are increasing your x, then moment will increase. Okay, and this also shows like it will be a straight line only. Okay, so see, so I am increasing x, right? So one thing also we are sure, from here we have to draw, like our movement is increasing linearly at after this point. Okay, So yeah, so see, so suppose I want to find moment at this C. So see 5 into 3, so I have to replace x is nothing but 3, so minus 5. See, this is 5 and this length is given 3, right? Yeah, okay. So 5 minus x, 5 into x is nothing but 3, so minus 5 into this is 15, sorry, minus 15, so it is nothing but minus 20, right? So see, at this section, at this C section, I am getting minus 15. So see, this is also minus, so this is increased by linearly, right? This increased by linearly, okay. Yeah, so this is nothing but minus 15 we are getting, right? Minus 15 Newton meter, okay. This will be Newton meter because it is movement, right? Yeah, after that, see after this, after the this is 50 Newton, and see at C, see, suppose this is your beam, right? And if you are applying moment like this, so see, in this case this beam will go like this beam will feel like this, like it will bend like this. So this is nothing but hogging, right? It is nothing but hogging. It is nothing but sagging, not hogging, sorry. It is nothing but sagging. So in case of sagging, you have to, the sign convention will be positive, okay. So see, this is your 3 Newton, so this is your minus 50 Newton. So see, minus at C, see at C I'm going to find. So see, at C, moment at C, see, moment at C will be, we have already got minus 15 minus, see, not minus, it will be plus, because this is sagging, right? So sagging we are considering positive, so this will be your plus 3, so it will decrease. So how much? It will be minus 12, okay. So it will suddenly decrease, okay, like this it will be decrease. And then, so suppose we have to do up to this, how much it is, it will decrease, right? So it will start from here, and next, then see, it will decrease. And then because of this see, suppose I want to find moment at B, suppose I want to find B. So see, B, moment at, sorry, moment at B. So I want to find moment at B. So see, this is your 5 Newton, so this is your 5, this is your 5 Newton, and moment, then this is minus, okay, this is also minus, and this next is this 5 into 3 plus 2, okay. This 5 into 3 plus 2, 5 into 3 plus 2, 5 into 5, so 5 into 5, and this 3 Newton is sagging, so this I have to add this, okay. So plus 3, so moment will be at point B. See, at point B moment I'm going to find, okay. So see, so this is nothing but minus 5 minus 25 plus 3, so how much it is, minus 30 plus 3. So see, minus 30 plus 3 is nothing but minus 27, okay. So from this, it's suddenly like it's increased, right? It's increased, so how much, 27. So, and in which variation, because see, this is nothing but what, this is nothing but your up to this it will increase, and this coming 27, so it will increase like this, it is also increase like this. And here how much, sorry, this up to this you have to increase. So this will increase like this. This is your minus 15, so see, this is your minus 15, and this is your minus 27, so it will come here, sorry, this will, and at this point your movement will be minus 27, okay. At this point your movement will be how much, so this will not, this is, at this point your movement will be minus 27, okay. Yeah, again due to this, this is going to be hogging, right? This is going to be hogging. So due to this, suppose this is going to be hogging, right? So in this case again your movement will be increase. So this is 27, again plus 2 you can add, so you will get finally movement at this here. How much movement you will get here, minus 27, and this is plus 20 plus 2, because this is sagging, right? Because this is sagging, sorry, this is hogging, so for that we have to add plus 2. So here finally we'll get minus 29. How much we'll get here, minus 29, okay. This will get here, will get minus 29. And in which variation, see at this point you will suddenly jump, like see, this is 2 Newton, suppose this is 27, and it will see, this is 2, sorry, this is 2 Newton, right? This is 2 Newton, this is 27. Due to this will suddenly jump, so it will increase like this, okay, and then we have to draw, then it will come like this, okay. So this is your movement for this, like this, okay, yeah. And here, so I want to find movement at A, so see, I want to find movement at A. See, movement at A will be nothing but, see, movement at A is nothing but 5, so this is your negative 5, so this is 5 minus this 5 into 3 plus 2 plus 2, right? So 3 plus 2 plus 2 is nothing but minus 5 into 7, okay, minus 5 into 7, yeah, into C. This is sagging, right? So this will be plus 3, so plus 3 Newton, okay, Newton meter, yeah. Then this is negative, so this will be minus 3, okay, minus 3, so this is going to be cancelled. Then your final bending moment at A you will get minus 5, and this is 35, right? So it is nothing but minus 40. So at the A, at point A you will get finally moment is minus 40, okay. So at this point you will get how much? Minus 40 you will get, okay, yeah. So yeah, so this is your bending moment diagram for this type of load, okay. So I hope you got it what I have explained in this video. So thank you so much. If you like this video, then share and subscribe with your friends. And also I have uploaded part 1 video related to SFD and BMD. So if you are interested, you can watch that video also. So thank you so much.